Hi, it's Terry Denery of the MathWorks. So, anyways, I want to continue from where we left off on the previous video. Previous video, we selected a motor and we were able to employ simulation because we could tell the mechanical linkage how we want it to move, and then we're able to measure the torque and the speed requirements. And it kind of explained how those are the key things for choosing the right motor. All right. So, anyways, this video I want to talk about feed-forward control for mechanics. And it turns out we've already done almost all of the work. Okay, and I want to demonstrate that for you right now. So let's just kind of go like this. All right. And I think you might know where I'm going with this. Okay, actually, I didn't do that well. Let's grab this and I'll copy it and move it over here. All right. So I have a second motor model now. And you'll recall that this four-bar linkage can exist in what I'd call a motion, mode or a force torque. So motion means we're telling it how to move. Force torque means we're going to send in the torque. All right. So let's return it to force torque. All right. And in a moment, we're going to take this torque and send it in. But just to kind of provide the baseline, I want to run this once. Show the two mechanisms and show the one that is receiving motion precisely moves the way we want, and the other one ultimately through kind of its unstable initial position will fall over. Okay, and will move kind of on its own as driven by gravity. Okay. So now I want to send the torque calculated by this one into this one. Close my email. Okay, and let's look at that. No, I'll just rerun it. Okay, and you see it's beautiful. So that perfect calculation of torque, sending it into that, four-bar linkage that's receiving torque, it's going to move precisely the way we want it to. So that's a terrific thing, right? And now I want to just kind of show through a little bit more demonstration the fragility of what we just did, right? And so instead of just sending that torque in, I want to add a little bit of noise. Right? So I'll bring in an add block. Okay. And so one component is what we just sent in. And we can see from this video, it's a component that ranges from like 0 to about 0.3 Newton meters. All right. And so now I want to go to Simulink sources, and let's just get a random number generator. Right. And let's zoom in here. Right. And I think I'll use a gain block. Okay, so random number generators produce signals that are on the order of 1, right? Okay, and so what I do is multiply this by 1e minus 7. Oops. All right, and so let's run this. From the Mechanical Explorer, we just hit this green button right here. And here's the point. We are adding noise that's on the order of 10 to the minus 7th of the value of the torque that's being sent into it. And all you can say is that as soon as it gets off synchronization, I want to use that, define that word a little better, but all bets are off. Okay, just a little bit of noise, and that's how unstable this system is. And we recall it's essentially like two inverted pendulums. All right, and so anyways, let's kind of get back to an overall strategy that's going to be based on, what's going to be definitely based on feed forward. So let's take all this stuff, and let's just throw it in a block, and we'll call it FF control. Okay, here's our command signal. Let's kind of move that up like that. And now let's take all this. We'll put that in a subsystem, and we will call this plant. Okay, we've got a lot of real estate now. Okay, so anyways, let's kind of set it up for our feedback. And our feedbacks could be on position. I think I'll just go ahead and maybe use this. So we'll send out that whole bus right there. Let's label these properly, right? This is our torque, right? And that this is our noise. Again, let's make some real estate. Let's bring in a bus selector. And this time we're going to pick off the motion from it, right? Okay, now the motion is a three-component signal, and it's going to be position, velocity, and acceleration, right? And I think I'll just kind of use my routine of typing in the first three letters. I'm getting a block called the selector block, all right? So it's a three-component signal right there, and we're going to only choose the first signal, which could be position, right? And let's use the same block right here on our motion command, which is position, velocity, and acceleration, right? And so now I'm going to get a sum block. And we'll use that signal as our feedback to compare with our command, and we'll just operate on the whole thing with the PID. Right? So plus, minus feedback, and essentially error calculations operated upon by the PID. All right, and so now it's just kind of, oops, not that one. How do I do this? Delete, and we'll just go add. All right, and it all works beautifully again. Okay, and I think I'm just kind of going with the defaults even. And that's, yeah, again, an interesting conversation why defaults work so well here. And it really does have something to do with the feed forward. So tuning a PID gets easier. And it means you can be pretty aggressive on what your, like your proportional and derivative and integral gains might be. But I think quite often, I think proportional does the trick. So, and I'm going to just kind of prove that to you now. All right, and so instead of having noise that's scaled by 10 to the minus 7, let's try 10 to the minus 1. All right, and maybe we'll put a scope on. You know what, it's better. Let's just look at the animation. Oh no, let's put scope because we'll kind of see how far we can go with this. All right, and let's hit run. All right, it works beautiful. Yeah, and we know that because we're not seeing any differentiation between the movement of the 4 bar used to calculate the ideal torque and the one that's responding to that torque, right? But now has a little bit of feedback and we're seeing perfect movement. So anyways, I just want to kind of state that feed forward is awesome and never, ever, ever, well, I'm going to be a little careful on that. Most often, you do not want to use feed forward all by itself, right? And we'll wrap up and we'll just say, hey, here's our controller. This is what it looks like now. We'll throw that in the same subsystem. All right, FDBK for feedback. Make it big and not bad. Pretty good looking controller, right? And I think where we'll go with this is talk a little bit about how you get that onto hardware. And I'll certainly point to the fact that that we're using a numerical methodology as available through SimScape Multibody probably will not be good enough to I'd say meet the software constraints that we're going to impose on our controller, and essentially that it can run on, I'll say, the embedded processor as C code, and that it's not too big. So, anyways, thank you.